NCERT exercise at page 143. Question number 1. How does the force of gravitation between the two objects change when the distance between them reduced to half? Suppose the distance between the object is d, then the force can be calculated by this formula: F is equal to G m1 m2 upon d square. But when the distance becomes half, instead of d we have to write d by 2. In this case, the new force F2 will be equal to G m1 m2 upon d by 2 whole square, and d by 2 whole square is d square by 4. So when we write in denominator d square by 4, this 4 will come in numerator, and the new force F2 become 4 times of G m1 m2 upon d square, means 4 times of original value. So answer is force would become 4 times of original value. Now question number 2. Gravitational force act on all objects proportional to their masses. We have already discussed in this formula. F proportional to product of their masses. But why then a heavy object does not fall faster than a lighter object? Means when we allow to fall any two objects which is heavy and lighter, they both will reach at the same time when released from the particular height. So the reason is, as F proportional to F is equal to ma, it means F proportional to m, where a is a constant. Means the force depend on the mass of the object, directly depend on the mass of the object when the acceleration is constant. Means on the earth surface or nearby the earth, the acceleration due to gravity is constant for all the object equally. Means the acceleration due to gravity does not depend on the mass of the object. So acceleration is constant for all the body with respect of any of the masses. That is why when the heavy and a lighter object allowed to fall from a particular height, they will reach at the same time, because small g, value of small g you can calculate by gm upon re square. Means it does not depend on the mass of the object, which is already cancelled while derivation. So small g can be calculated by capital G, mass of the earth, radius of the earth square. What is the magnitude of the gravitational force between earth and a 1 kilogram object on its surface? For this, mass of earth is given 6 into 10 to the power 24 kilogram, radius of earth is 6.4 into 10 to the power 6 meter. As the force between the object and earth can be found by the help of G capital M small m upon R square, where capital M is the mass of earth and capital R is the radius of earth and M is mass of object. Now we can place the value of capital G, which is 6.7 into 10 to the power minus 11, capital M mass of earth, which is 6 into 10 to the power 24 kilogram, and in denominator radius of earth 6.4 into 10 to the power 6 whole square. Whereas the mass of object is only 1. Earlier we did this kind of calculation in the calculation of acceleration due to gravity. The value of 6.7 into 10 to the power minus 11 into 6 into 10 to the power 24 upon radius square is only equal to 9.8. So you can remember this calculation, it will be 9.8 into 1, 9.8 Newton, because the mass of object is only 1 kilogram. Now question number 4. The earth and moon are attracted to each other by gravitational force. Does the force of earth attract the moon with a force greater or smaller or same as the force with which moon attract the earth? And why? As both the earth and moon attract with same force, the force of attraction applied by the earth on moon and moon on earth is equal, because the third law of motion we state that force of action and reaction are always equal and opposite. That is why the force of attraction applied by the earth on moon is equal but opposite to the force applied by the moon on the earth. 5. If the moon attracts the earth, why does the earth not move towards the moon? In the answer of this, the force exerted by the earth on moon is used in attracting the moon in a circular path. Means whatever force of attraction takes place by the earth on the moon, it will use to make the moon in a circular path. It accelerates the moon into the circular path because this force acts as a gravitational centripetal force. The moon attracts the earth with the same force, but the earth is too heavy to move. It means the acceleration applied by the moon on the earth can be calculated by A is equal to F by m, where m is the mass of earth, which is too heavy. That is why the acceleration produced on the earth towards the moon is very small, negligibly small. So it will not accelerate towards the moon. Now next question. What happened to the force between the two objects if the mass of one is double? If the mass of one object is only double, since the original force F is equal to G m1 m2 upon d square. If one of the mass is double, it means instead of m1 we will write double of m1. In this way, the expression becomes 2g m1 m2 upon d square, which is equal to twice of original force. Means F2 is twice of original force. So when the mass of only one object is double, the force becomes double. And second part, the distance between them is double and triple. So first of all, in double case, original force is g m1 m2 upon d square, but when the distance is double, it will be g m1 m2 upon 2d whole square. Means in denominator 2d whole square, which is 4d square will come. It means the new force F dash will be equal to 1 by 4th of original force. But when the distance is triple, then the new force F2 will be equal to g m1 m2 upon 3d whole square, and 3d square is 9d square. Means in denominator 9 will come additionally. That is why the new force F2 will be 1 by 9th of original force. In the third part, it is asked that when mass of both the object is double, it means the new force F dash suppose will be equal to g double of m1 double of m2 upon d square. This 2 into 2 become 4. It means the new force F dash will be 4 times of original force F1. So when mass of both the object will be double, the force of attraction between them will be 4 times of original value. Number 7. What is the importance of universal law of gravitation? We have already discussed, due to universal law of gravitation, we all are bounded on the surface of earth. The motion of planet around the sun can be explained with the help of universal law. The motion of moon around the earth, the exactly same phenomena. Third, falling of rainfall or snowfall is due to the universal law. Fourth, the flow of water in the rivers. So these all things we have already discussed. Question number 8. What is the acceleration of free fall? The constant acceleration of an object produced during the free fall is called acceleration due to gravity. It is a constant in nature and its value is 9.8 meter per second square on the surface of earth or nearby the earth surface. Question number 9. What do we call the gravitational force between earth and the object? The gravitational force between any object and the earth is called force of gravitation by the earth, or simply we can call gravity. Question number 10. Amit buys a few grams of gold at the poles as per the instruction. He hand over the same when he meet at the equator. Will the friend agree with this weight of gold bought? If not, why? Obviously the answer is no, as the value of small g means acceleration due to gravity, which is greater at the pole and it is smaller, slightly less at the equator, because the radius at the pole is shorter than the radius of the equator. That is why Gp is greater than Ge. Means acceleration due to gravity is more on pole in comparison of equator. That is why says the weight of object is equal to mass into gravitational acceleration. That is why weight of object on pole will be more than the weight of object in equator. Or conversely, we can say weight of object on the equator will be slightly less than weight of the object, same object which is measured at the pole. That is why the friend will disagree with the same amount of gold if it is first weigh on the pole and then the way is taken on the equator, because the equator the weight of the same object will be reduced. That is why.